Good morning, ladies and gentlemen. Today, this video is not going to be of my face, but mostly of my voice and of this screen. I'm going to be showing you with a model example what you'll be doing with the two assignments that are due on Friday. They will involve some math, so I'll give you a moment to stop panicking. With this math, it is not hard. You can do it with a calculator. I only ask you double check your work because it's going to be very, very easy for you to make mistakes if you don't key in your numbers correctly. Also, you can do this work longhand, meaning just write out the numbers and do the work the good old-fashioned way. It will not kill you either way that you do it. So last week I introduced the idea, or rather the other day, I guess it wasn't that far ago, I introduced the idea of sectionalism, that the U.S. started dividing into sections, and that James Madison had made the observation that the differences between the sections of the U.S. between North and South didn't lie between the size of the states physically with their population, but between whether or not those states had slavery. Now, we know from my last video that the words slave or slavery are not mentioned in the Constitution, and that enslavement is only mentioned first in the 13th Amendment. So, one of the things I had you write down with the roots of slavery was the 3/5 compromise that you learned about last year in civics class. Now, the 3/5 compromise was used to help states determine their population. Now, at the Philadelphia Convention, free states only wanted to count free people. One of the reasons they wanted to do this was because they thought slavery was bad and evil, and in a way, that would be punishing states that owned slaves. But at the same time, states that were free states had larger populations, significantly larger populations. And because they had larger populations, they would have had more representatives in the House of Representatives. This would have given them more votes and more power. The southern states had smaller free populations. That meant they would have had fewer representatives, less votes, and less power. They knew this, and this is why they forced the 3/5 compromise. The Southern delegates at the Philadelphia Convention threatened to walk out and let the Constitutional Convention collapse, and with it the United States would have collapsed as well. If you think back to everything we talked about with the preamble way back in January, all those things that we were talking about that were wrong with the United States would have come true if those Southern delegates had walked out. So there's a compromise made. All the states get to count their free population to determine the number of representatives they get in the House of Representatives according to their respective numbers, meaning they're free people. Those free people included those bound to service, excluded Indians that did not pay taxes. And then we get to the fun part in the Constitution when it describes slaves as other people. So 3/5 of other persons. For us, we know that means slaves. So you and I all know that you can't have 3/5 of a person. I'm going to look at one of my great artistic ability skills here. Here we have person. If we're going to make him be 3/5, right now he is whole. To make him 3/5, we'd get rid of his legs. And this area in the circle that I'm shading in would remove that section of the circle. Problem is, even though we removed his legs, he's still a person. So that's not what the 3/5 compromise meant. What the 3/5 compromise did when they counted non-free persons was it took 1, 2, 3, 4, 5 non-free and made them equal to 3 free. So whenever they counted, say there were 45 stick figure non-free, you would divide the number 5 into that. No, you wouldn't. Oops, pardon me. For every 5, you'd get 3 free people. So you'd have to figure out how many times 5 goes in it. So I was right the first time. You divide it by 5. So 45 divided by 5 equals 9. That gives you how many 5s there are. And then you would take the number of free people, multiply that by 3, and the non-free population would equal out as 27 free people because of the 3/5 compromise. Now that's probably confusing the living daylights out of you. So let's go on and use some real numbers to show you what I'm talking about. So first off, let's take a look at the instructions here. The instructions are very important. I suggest that when you go over the instructions, you highlight them as well. So first off, you're going to be calculating the number of representatives that each state would have in the U.S. House of Representatives based upon the population and exchange rate provided. So here are 2 very important things you need to pay attention to. One is the free population numbers that I give you, which are column A. Then you have the slave population numbers, which are column B. Now, because of the 3/5 compromise, I've kind of done a little trickery in here for you. Because of the 3/5 compromise, free people equal free people. That means you take the free population number, you multiply it by 1, and the free population number never ever changes. So this column A, you do not do anything with. The first work you have to do is with column B. Column B is where you have to apply the 3/5 compromise, where you have to get 5 slaves to equal 3 free people. So the easiest way to do that is to take 3/5 and turn it into a decimal. If we stretch this backwards to tenths, 6/10 equals 60%. But that's a percent, that's not a decimal. As a decimal, %60 is 0.6. And if you follow that 0.6, you'll notice I have provided it for you. So with the slave population column, column B, you multiply the number of slaves by 0.6. I'm going to do that longhand off to the side for you, and then I'll do it on a calculator. So, the number of, let me backtrack. I mentioned up here the exchange rate. The exchange rate is, for the first Congress, how many people a state needed to have in order to get one representative. So for every 30,000 people, you got one representative. When you get to the last column where it says number of representatives, you may end up with a decimal. If you end up with a decimal, each state must have at least one representative. So if it's 1.7, you drop all decimals. So 1.7, cross out the 7, it just becomes 1. If it is a decimal of 0.73, then you would round it up to 1. Each state always has at least one representative. So there should be no zeros. And no decimals. Okay, so let's go back over here. I'm going to go back over. I'm going to take the population of Delaware, which in 1790, from the first census, the population was 46,310. Excuse me, the free population was 46,310 people. The slave population, or non-free or other person's population, was 3,899. So going over to the right, I'm going to do 3,899. Multiply that by 0.6. That decimal is very important. So 9 times 6 is 54. Put the 5 up. 9 times 6 is 54. Plus 5 is 59. Carry the 5. 8 times 6 is 8, 16, 20, 48. Yes, I still use my times tables. Carry the 4. 6 times 3 is 18. Plus 4 is 22. There's no second number here. So we have this big number. Now from math, anytime you multiply and you got a decimal, you got to carry that decimal down. We have only one decimal place here. So moving in from the left, you got to bring in one decimal. So for right now, we don't care about anything after the decimal. All we care about is that 3/5 of 3,899 is 2,289. So you'd write 2,289. For the third step, you're then going to take and create what I call a total adjusted population. With the total adjusted population, you're going to take the number from column A and the number from column B. So the number from column A is this 46,000 number. So 46,310. And I'm going to add to it this column B number. 2,289. Now, I don't want to see this on your paper. I'm just doing this as an example so you can tell what I'm talking about. And add it up. So let me do this math off on the side here for 6310 2289. Make sure your numbers line up appropriately, and we are adding them. So 9, 9, 5, 8, 4. So that's 48,599. That's the adjusted population when you take the number of free persons and 3/5 of the non-free persons. The last thing we do then is we take whatever we have as column C and divide it by 30,000. And that gives us column D. Now this is where, remember, there are no zeros and no decimals. So the nice thing is, if we take this 48,599 and we go old school division, one of the things that we can do to very quickly figure out what the number of representatives is start knocking off numbers. What I mean by knocking off numbers is, who really wants to divide 30,000 into 48,599? How about we divide 3,000 into 4,859? Or 300 into 485? Or how about 30 into 48? That makes the math a whole lot easier. 30 goes into 48 one time. 30, 0, 1, and that's subtracting, 8. Now 30 does not go into 18, so we'd bring down a 0. That doesn't exist. Put a decimal up here. 30 goes into 18 6 times, giving us a remainder of 0. So we put 1.6 here. But it says no zeros and no decimals. So we go back, chop off the 1.6, and Maryland gets only 1 representative. Now give me a moment. I'm going to jump over, open up my calculator, and I'll go back and forth using the calculator to do the next column. Now the fun part is figuring out where my calculator actually is. Hey, there we go. Got on the first try. That's pretty amazing. Now, if only I knew how this calculator worked. Where's it clear? Ah, there we go. All right, let's go back over. All right, so taking a look, we're going to be doing Georgia. Georgia's free population. Column A, 52,886. So remember, in column C, we're adding A and B together. So 52886. I'm just putting that over there as a reminder. And then we have to take 398, multiply it by 0.6. So let's go over to my calculator. 398. So 3. Oh, yes, it's fantastic. No. 398 times, and then you have to hit the decimal button, 0.6. And that gives us 238.8. Remember, we do not care about the decimal, so we're just going to take the 238 over. That 238 goes right here. So we'll add these two together, 238